In this video, we continue the Blazor journey by showing you some common use cases that you will run into when building Blazor applications. The first of these is creating components. Components function similar to controls in technologies such as .NET MAUI, WPF, WinUI, and many more. In Blazor, they are basically a combination of user interface and code behind logic that encapsulates some behavior that you want to be usable in multiple locations. In our demo application, for instance, we can take the entirety of the login functionality and move it into its own component. The process of doing this is quite straightforward. Just create a new Razor component file and copy the UI and code behind, if any, into it. You can then place that component in any page and you get that functionality. Let's run this and see this at work. As you can see, the UI continues to show up. And if we add some breakpoints in the code behind, we can see that the object is properly passed in and the method invoked. Any page in a Blazor app is a component, and any component can be turned into a page by adding the @page directive at the top of it and providing a path that indicates to the framework that the page should be used for rendering that path's content. If you've used MVC, you will be familiar with this. All page directive paths must be started with a /. To specify that a page is a default or root page, simply specify a / alone. Let's change the site up a bit by converting the login component into the default page and giving the home page a specific path. You can now see that the login page is the primary page and the first page that's loaded. And if we type landing, it takes us to the home page. Multiple page directives can be added to the same component. This is usually used in scenarios where the same page is used for rendering multiple paths, typically due to a path parameter being used. We'll get into that in a moment. A component can also directly navigate to a given path like any other web application using anchors as an example. On the notion of multiple page directives, wildcards can be added to a page's route to allow for a measure of variability in the page. The capability requires a property to be specified in the code behind that will be used to represent that wildcard. This property is then added to the route. When the route pattern is satisfied, the value of the wildcard portion of the route is assigned to the property. To enable this, the property must be decorated with a parameter attribute. And this takes the testing 1, 2, 3 part of the overall path and applies it to the property, and then that property is displayed here. Parameters can be constrained to given types or be specified as optional using the question mark character. So if I convert message to an int, this page will now generate an error because the default behavior for message is that, as you can see up here, it's expecting a string. Even if I pass in numbers, it still crashes because that is being treated as the string 1, 2, 3 and not as the number 1, 2, 3. To explicitly constrain it to a certain type, you use the colon and then you type the type name. Now when we run the same code, it properly works. The cool thing about this approach is that if the wrong type is specified, the page is not even hit. It's like it doesn't exist. The constraint types are bool, datetime, decimal, double, float, GUID, integer, and long. To make the parameter nullable, add a question mark after it. Doing so means we don't need the top page directive because it's essentially superfluous. Whether message is there or not there, this page will be called. Parameters can also be specified as catch-all by prefixing the wildcard with an asterisk. When specified like this, everything after the static part of the route is passed into the parameter. Finally, query strings can be used as well, and you can bind properties in your code behind to them by decorating them with the supply parameter from query string attribute. Note that as parameters are typically optional, the underlying properties should be nullable in order for you to identify when they don't exist. And if the parameters are not specified, Blazor, like MVC, uses the concept of dependency injection as one of the mechanisms for adding functionality to a given app or page. Dependencies are injected into the app in the program.cs file. When we added the server-side interactivity by calling add interactive server components, we were using the dependency injection patterns built into the framework. To use dependencies on a given page, add a property of the type that is to be injected and decorate it with the inject attribute. At runtime, the framework will supply a value for that property, so you can assume that the property always has one. That being said, please note that for this to function properly, the object must have previously been added during the initialization process. For certain dependencies, like those responsible for reading configuration files or navigating from page to page, this is added by default. For others, like the ones you create, you will have to add the dependency first, or the value of the property representing the dependency will be null. You can also inject dependencies in the markup view itself using the @inject declaration. Navigation from page to page can be done in two ways. First, you can use the traditional anchor HTML control to simply pass the path to the other page you want to navigate to. Secondly, you can navigate to the page using the dependency to an object called Navigation Manager. Let's inject a Navigation Manager into the login page and use it to navigate from there to the home page when a user's credentials are correct. So this looks good so far, but right now our credential information is hard coded into the app. So if this were deployed in several places, the credentials would all be the same. Normally, this would be put in some kind of data store, but for the purposes of this example, let's put it in a configuration file so it can be read and used to validate the user. In Blazor, you can use the app settings JSON file for this. Let's add a username and password value to the file with some default values in them. To read the configuration, inject a dependency to iConfiguration. For this case, I'll use the other way that you can inject dependencies into a component using the inject attribute associated with a property in the code behind. Now, inside the onLogin method, we can read the configuration values and check them against what was inputted by the user. To prevent name collisions, I've changed the settings values to say admin username and admin password, and I've also made a change in the app settings.json. Now when I click the login, it should have the values from the config, and this should fail. And if I enter the right value, once again, you're all signed in. Let's take this opportunity to create a new project for Blazor WebAssembly and show you how to connect the two together. Although the Blazor Web App template can be used here, let's use the standalone WebAssembly variant so we can see all the things that need to be done to get it working with its server counterpart. Now, remove the layout folder. Remove the home and weather pages. And remove the app.razor component. Because this isn't an actual standalone site, you won't be needing app.razor, so remove all references to it from your program.cs as well. Remove all the contents of the www root folder. And add this project as a reference to our main sample project. We'll also need to make some changes to the server side of the project. Firstly, add a package reference that enables the client-server interoperability. This NuGet package adds some additional methods that allow us to add client-side interactivity to our server-side code. At this point, if we added the new counter component to the login page and ran it, we would see that everything works as expected. There is a problem, however. If you try to enter the URL for the counter page into the browser, you will note that the framework does not route there. This is because the capability that registers pages for routing does not know of this additional assembly. It is currently only searching within the assembly of the server application and not any reference assembly. Let's add code that identifies the referenced WebAssembly as an additional assembly to be searched for page components. Okay, so now it's addressable, but note that the interactivity is still not there. So let's add it by setting this page as being interactive. This is done the same way as with Blazor Server, but in this case, we use interactive web assembly as the render type. All working fine now. C# has a capability which allows for static usings. We can use that to simplify the render mode directive. In the imports.razor file in the WebAssembly project, we add the following. Using static makes the public members of any type available wherever this declaration is made so that you don't have to specify the type name. Because of this, we can change render mode.interactive WebAssembly to just interactive WebAssembly. Once the user is logged in and on the landing page, we will add some interactivity there that simply navigates them to a page on the WebAssembly side of the fence. You can use JavaScript from inside of a Blazor application as well. This process starts with injecting the JavaScript interoperability dependency into the application. It's called IJS runtime. To call JavaScript functions from inside here, we use the invoke method of this object. In this case, we can simply use the eval method to invoke an alert on the screen. Note that JS Interrupt does not work on static server rendered pages, so interactivity must be enabled for it to function. Also note that this property will be null until onAfterRendered is called, so don't try to call it using oninitialized. JavaScript interrupt can also be used for Blazor Server. Although reading configuration values from WebAssembly is essentially the same as on the server, the location of the config file is different. For Blazor WebAssembly, the app settings.json file must be located in the root of the www root folder. I've now copied the same app settings that existed here over into the WebAssembly. And I'm going to just read those settings and pass them into the alert that the JavaScript triggers. Let's run this again and make sure it all works. Blazor WebAssembly sites are running on the client side, not on your server. So connecting them to the server will require using the HTTP client to call back to the hosting server. This is done by injecting the HTTP client and simply calling the backend service, or really any service of your choice. One thing to note is that the WebAssembly projects are pre-enabled with a call to add HTTP client as a dependency in the program.cs file. This sets up the HTTP client with a base URL, that is the URL for the server where the WASM file is hosted. For server-side Blazor, this is not the case. Fortunately, Navigation Manager has a base URI property that gives us that information. We can essentially prepend it to any service request to get the full URL for any resource on the server side. To add the ability to create services on your Blazor server project, go to the program.cs file and add controllers to the services collection, and then map those controllers as you would any normal web API project. Let's add a controller to our server project and then call it from WASM. So here I've disabled the overall controller routing, and I'm basically creating my custom routes for each request. I've added an echo service, which essentially takes a message and returns back "you said," then the message. And I've given it the route of API echo, and then there's a placeholder there for a wildcard message where you can pass whatever the message you're passing to the service into. That placeholder, like in Blazor pages, is basically passed into a parameter for the method so that we can use just the placeholder wildcard text within our response. In our WebAssembly file, we'll inject the HTTP client, and then we'll add a button that we can use to call that service. Next, we add a place to hold the response from that service call. And then we add the call service method. All call service does is make a call using the get async to the URL for our web service, passing in the arguments test123, and then the response of that call is essentially stored in message. After being stored, we call state has changed to refresh the UI and re-render. Finally, let's place the message somewhere. Now let's run it and see what happens. So one thing that you're going to notice once I actually click the login and I click on this counter is that this is actually going to fail. And before I do that, I just want to make sure that you can see that over here, I'm using this client, which I have actually injected here, right? And if we go to the code behind, I'll close everything. If we go to the actual program, you can see that I've added that service here. But now when I run this, you get this error that says cannot provide a value because there's no HTTP client. This is somewhat difficult to understand, but there's a real rationale behind it. Remember again that the hosting process for everything that we're doing here is not the WebAssembly project. It's actually the server project. That's where everything is being configured. So the reason why HTTP client is not showing up here is because you actually have to configure it on the server side. So we can go over here, just add it. So this adds the HTTP client. Oops, looks like we omitted something. This should say Now we try it again. And as you can see, it's called the service and come back. Now, Blazor also includes the concept of layouts, which, as the name implies, lets you specify a default layout that all pages that leverage it will adhere to. Going into the default layout of the application, you can see that there is a common structure that pages follow. Anything modified here will apply to all pages. To see that at work, let's remove the nav menu, which doesn't add any value for this particular kind of application, from all pages by just deleting it here. And now when we run the application, you should see that it doesn't show up as we jump from page to page. Here's our login. Here's a landing page. And here's the counter page. You can also specify sections here, and any pages that leverage this layout can add content that is targeted to those sections. We'll modify the About Blank section up here to leverage that. Remove the nav menu. Now on the home page, we'll add a section content area which targets this specific section of the page and adds that about link to it. The cool thing about this is it can be added anywhere on the child page. To reference the specific section outlet that you want to add content to, you must use the same section name. As you can see, the about is there. But if I go to the count, the about is missing. If I go back here, the about is there. And obviously on login, there's also no about information. This concludes our sessions on Blazor Web Apps. With the information provided here, you should have all that you need to start building powerful Blazor applications, from static server render to interactive server, and finally Blazor WebAssembly. If you have any areas that you want me to go into, questions, or issues related to Blazor, please leave a comment below. Also, if you have any requests for topics you would like me to tackle, leave a comment below and I'll work it into the schedule. Hope you enjoyed the video. Happy coding and have a blessed day.